Hello everyone and welcome to another episode of Investigation. And in today's episode of Investigation, I will go over our first rule in differential calculus, and that is the power rule. And as you can see, this is the power rule listed, and we'll go over some sort of intuitive feel and the proof of power rule using our definition of derivative that was derived from the last video. So let's review a little bit over here. So the definition of derivative would be, in the coordinate plane, the slope of the point at that instant. So if I have, let's say, a line over here, so let's move that. So the derivative of this function at this x value would just be the slope of this line over here, the instantaneous slope, or the rate of change of y with respect of x. So let's go over. So the power rule would be that the derivative with respect of x to the nth power would be n times the x of -1. And that is actually derived from the binomial theorem, if you wonder, and we will go over the proof right now. So first of all, let's go over some intuitive feels of the power rule. I've graphed some functions on decimals. This graph is gotten from decimals. And let's see. So if the f of x is x squared, this red parabola over here, then the f prime of x is a straight line we see over here. So the function of this straight line, let's say it passes over 0, 0, and it also passes over, let's say, this point, which is 1, 2, meaning that this the equation would just be 2x. And let's take a look at this one. We have the original equation as a cubic, and obviously over here it is deduced to a quadratic, which is 3 minus 1 power, and that we know that it passes 0, 0 with the vertex over here, and it passes 1, 2 as well, and -1, 2. Thus we know that this equation would just be 2x squared. And let's wait, actually that is not 1, 2 over here. Oops. So this would be 1, so this point, so that's 1, 3, and this point it will be -1, 3. So that would give us our equation 3x squared. And now let's go over the proof of the power rule. So the power rule, let's start off with, let's say, let's define a function f of x, and that function is equal to x to the nth power. Obviously n cannot be equal to 0 for obvious reasons, but n can be equal to any real values other than 0. It can even be negative. Let's see, we have f prime of x, or this is another way of saying d dx. So f prime of x will be the limit as h approaches 0. I would like to use h over here because I don't want to write delta x every time, and that kind of messes with my brain of, wait, is this delta x or x? So we will just use another variable to ignore, to bypass this kind of annoying thing. So that will be the slope, so h, f of x plus h minus f of x, and that is obviously reduced to limit as h approaches 0 of h of x plus h to the n minus f or x to the n, and using the binomial theorem to expand this out, we have, so the denominator we have h, and the numerator we have xn plus xn minus 1 times h plus, wait, actually we have a coefficient over here, n choose 1, xn minus 1 h, and choose 2 xn minus 1 h squared dot dot dot, and then plus n minus n h n times, wait, actually n minus I n would just be 1, right? And that would be minus xn. And we have this, so we can deduce that to, so this and this term would just cancel out, and this denominator h would cancel out with each of this. So this numerator would cancel out, cancel out, cancel out. Now we just really have, well, actually, this numerator only cancels out this portion. So that will become 1, that will become n minus 1. So then we have n minus 1, x, n minus n, n minus 1, and then n choose 2, x, n choose, and then plus dot dot dot, plus n choose n, h, n minus 1. And we notice that we are limiting that to h approaching 0. So any terms approaching 0, so that will just be 0. So all of the terms after that will be cancelled out because they multiply by at least 1 h. So then, yeah, there's no h in this term, so we can just simply get rid of the limit and say that would be n choose 1 x n minus 1, which obviously will just be n times x to the n minus 1, which is exactly what we have over here in the power rule. And that is the power of derivatives, and it is very, very useful combined with the constant multiple rule that we will go over in the next 2, maybe 3 videos. And that is very useful and pretty much all you need to differentiate a polynomial. And that's pretty much it for today. Thank you for watching and have a great day. Goodbye.